All right, so we're going to talk about a few transformations, and we're going to use this super awesome interactive tool online, and I'll post a link for this tool with the video, but it's from shodor.org, so it's really cool. All right, so first let's talk about translations. If you are moving right or left or up or down, that's going to be a translation. A translation is just a fancy math word for sliding or shifting. So let's see what happens if we move a figure 3 units left and 5 units up. Alright, so if you start with the red vertice, you could just count. We moved it 1, 2, 3 spaces to the left and 1, 2, 3, 4, 5 spaces up. Alright, and that's true for every vertice. You just move each point 3 units left and 5 units up. One thing I want you to realize for your mapping rules is that if the x is positive, think about the x-axis being positive, we're going in the right. We're moving in the right direction. If the x is negative, you're moving left. If the y is positive, you're moving up. And if the y is negative, you're moving down. So that's a little bit about translations. Let's look at one more. Let's move. I want to move in the right direction. I want to go to the right, which means my x value has to be positive, so I'm going to shift it 8 units to the right. And then I want to shift it down, which means my y value has to be negative, so I'm going to shift it down 4. And there you could see if you just took one of the vertices and checked, you could start from the purple, you would count over 8 units and down 4 units. That's a translation. Again, we're just sliding or shifting the graph. Okay, so now let's talk about reflections. Reflections are a flip. If I want to reflect across the line y equals 0, first let's talk about where that's at. Y equals 0 means that you want the line to cross the y-axis at 0. So y equals 0 actually ends up being this x-axis because it crosses the y-axis right there at 0. So when we reflect across y equals 0, we're really reflecting across the x-axis. And so here's what it looks like. We have flipped it over the x-axis. Let's look at a different one. Let's look at y equals 3. Nope, let's do y equals negative 3. If we reflected across y equals negative 3, first let's visualize where that line would be. We need it to cross the y-axis at negative 3. So that's going to be a horizontal line crossing that y-axis at negative 3. So let's see how that looks. Oh, just kidding. This is in slope-intercept form. I totally lied to you guys. I put the negative 3 in the wrong spot. I want it to have 0 slope. Oops. Let's try that again. This is reflecting across the line y equals negative 3. All right. And again, we're just flipping it across that line or folding it across that line. I also want to mention if you reflect across like if you have a line x equals 2. A lot of times when we see a line x equals 2, we expect that to be a horizontal line. But you have to ask yourself, okay, that means it's crossing the x-axis at 2. And in order for it to cross the x-axis at 2, it would have to be a vertical line. So let's see what that Let's see what that looks like. Okay. So this is a reflection across the line x equals 2. And again, x equals 2 means that it crosses the x-axis at 2. So that purple line is your line of reflection, and we have flipped it across that line. All right, we're also going to talk about rotation. Sometimes these are the hardest to visualize, so this is pretty awesome. We're going to take this shape and we're going to rotate it. Let's do 45 degrees. Sure, why not? Oops, that would go off the grid. Let's see how many times I can mess up. All right, let's rotate it 180. So what we've done is we've taken this figure here and we've turned it 180 degrees. When you rotate 180 degrees, you're actually doing 2 reflections. You're reflecting it across the x-axis and the y-axis. So you would reflect it both axes, the x-axis and the y. That's the same thing as rotating 180 degrees. You don't have to rotate 180 degrees. You can rotate any degrees. Let's rotate 90. And there you go. We've rotated it 90 degrees. All right, that is just a little bit about transformations. In the next video, we're going to talk about dilations. The only transformation we haven't talked about yet.